What's up, everybody? It's David Ariev, finally back to you guys again for yet another excellent Octane tutorial for eyedesyn.com. This week, we're going to be taking a look at the mysterious, the unknowable feature of Octane 2018 called Vectron. It's a fractal renderer. It does a lot of really weird things that are hard to understand, and I've deciphered it a little bit, but not that much. Really, I'm just showing you my process of experimentation, of choosing colors, of choosing lighting, and combining techniques that I learned in the past. I hope you enjoy it. Let's check it out. So one of the craziest new features of Octane 2018 is called Vectron, and it allows you to render fractals. And I'll show you what I mean here. If we come down to Objects and pop in Vectron, and we get this sphere with some weird code over here. Now if we come to Script category, we can choose Vectron, and then under Script presets, we can choose Mandelbrot text. And there you go. If you play with the power, you get some really weird animation, and you can create some interesting formations. And then of course you can throw a daylight object on it, and then for good measure, let's just put a colorful background behind it, like a blue here, and then we'll set this to mix sky texture, and there you go. Post it straight to Instagram and you'll be famous. Wait, no. Now you'll be famous. But in all seriousness, this thing is cool. It's just hard to know what to do with it yet. But I've done some experiments and tried to think a little outside the box, and here I'll show you what I've come up with. Okay, so here in this exemplary piece of abstract art, I've jammed a bunch of fractals together and put my little astronaut dude here sitting on a fractal, so I could do all the tropes in one image. If you combine two cliches together, then it becomes unique. And here's another angle. I didn't like this render nearly as much, but still kind of cool. So things started getting fun once I began playing with animation, and this was really surprising because I did very little work to actually get this to look super inky and interesting. I'll show you how I did this in a bit. And this one's interesting, almost feels like a procedural noise is revealing it, or something you would get with the new fields options in C4D R20, but also extremely easy to create. And people assume that here I'm using a glass texture on the fractals, but really I'm just mashing a bunch of fractals together, and you get some really strange and kind of awesome results. A lot of this comes from inverting the power of certain fractals, which does some things that are kind of beyond my comprehension and break my brain a little bit. And here again, this is just another fractal with inverted power, and we get some pretty inky looking results with a lot of detail. And after I posted this on the Octane Facebook group, someone had the really smart idea to take this and then use it as a displacement map. So taking that same texture and mapping it onto this terrain gives it some unique emergent properties. I really like creating one thing and then using it for something else. Okay, so here's where I took things one step further and I started to really like the results I was getting. So here I was just using the raw render, which looked like this. But for the next set of renders here, I started rendering Z passes, and that got me much more accurate displacement. Now here I'm just extruding these a little bit so we get these slight ridges that will catch the light, and it almost has this ink on paper feel, or a Rorschach test. Especially this render has this creepy and organic feel because of the bilateral symmetry, which makes you kind of see faces and eyes staring at you. And here, because of the top-down view and the slight extrusions, it really has this animated cartoony feel, almost like cardboard cutouts. Well, at first, but then it just kind of goes crazy. And for these, I seriously cranked up the displacement and got this even more unique look, which to me feels like cities building themselves as the fractals evolve. And finally, I dove back in and took one last crack at it and came up with this look, which is way more sci-fi with a bunch of volumetrics and texturing the fractals in kind of an interesting way. I definitely like this abandoned city vibe, and I added a LUT that really constrains the color palette and emphasizes these nice bluish green tones. And this one here, I'm actually using two different types of fractals, one for all of this geometry you see here, and one for the middle that's a little more blobby. And I'll make sure to show you how I built this. And last but not least, I got a little carried away and made this little animation here. This little dude's just so curious. Alright, so I just wanted to get you guys a little bit hyped about the eventual potential of fractals by showing you some other software that uses fractals and where Otoy could eventually take Vectron and all the possibilities out there for it. So this guy, Julius Horsthuis, is kind of a genius at using Mandelbulb 3D, which is a standalone fractal renderer that's been out there for a while, but he's just been picking away at this stuff and messing around with it for years and years and years, and he's developed this really cool style and very unique imagery using this software. And he's just able to build full cities with this stuff, and it just looks otherworldly and cool. Now, I don't think the renderer treats the light as nicely as Octane does, so that's where it gets exciting. If more of these art directable qualities are brought into Vectron, then we'll be able to really make some unique and interesting looking stuff. I also found this. Even Unity has some fractal rendering capabilities. There's this thing called Fractal Toy, and it's awesome to see with just a few changes in parameters, you get some dramatically different looks, and animating between those is also extremely cool. I love these light pulses that are traveling down the fractals here. And finally, this is a really great article you should check out on all the fractals in Guardians of the Galaxy Volume 2. So if you look at Ego's home planet and the columns and the floors, you can see that there are these fractal patterns everywhere. And 3 studios, Weta Digital, Method, and Animal Logic, all had to come up with their own means of handling these fractal forms, because Ego, this character, is basically God, and his home planet is meant to evoke infinity and all of these crazy, impossible forms. And you can really see it here in every column. There's all this crazy detail, and you can see it in the floor here with these recursive branching patterns that's all driven by insanely complicated math. And while Animal Logic was responsible for the palace, Weta was responsible for these external environments. And Animal Logic actually created a system of converting fractals in Houdini into point clouds and then geometry, and allowing artists to find attractive looking fractals with bounding boxes, and then they would locate those coordinates so they could instance that geometry and duplicate it across several columns, for instance. So here's some crazy fractal columns. Now, the interesting thing is it's apparently really difficult to convert fractals into actual geometry, but the way that Weta cracked it and got the detail that Mandelbulb 3D was able to create in geometry form was actually a really interesting solution. This one artist ended up using Mandelbulb 3D to do full turntables of fractal forms that he really liked, and then took that into a photogrammetry program, which then converted that into geometry. But hopefully this just gets you inspired for the potential that this kind of stuff has. It's very limited at the moment, but it looks like the toolset is going to be expanded to be more art directable in the future. So let's take a look at what's actually there right now and what we can do with it. Now, in order to actually get this feature, you'll need to sign into your Otoy page and then go to the forum and come down to Cinema 4D's forum and then go to releases. So here, the latest stable version is a version of Octane 4, but below it is Octane 2018. And in the future, Otoy is just going to release updates like Adobe does, 2018, 2019, etc. So here's 2018. Just come down and choose whether you've got a regular or a subscription build. And download. And of course, you want to put it in your Cinema 4D plugins folder. It's the C4D Octane folder, and you'll want to delete the files associated with any other version of Cinema 4D than the one you're currently using. I'm on R20, so I'll get rid of these. Alright, so again, the way we add in a Vectron object is just here under Objects, and then Vectron, and I'll start the render going. And let's just start with the simplest type here, which is under Vectron, let's choose Mandelbulb. Alright, and let's dolly in a bit because the fractal gets a bit clipped off until we get closer. And there, now we're actually seeing a lot more of it. Now, looking at these weird ring structures here, this is something that I feel like I've seen before, and it made me think of ray epsilon. So if we come over here, and I'm going to undock my settings so we can take a look at both at once. And if we come over to ray epsilon and start messing around with this, sure enough, this dramatically changes the look of our fractal. So if we come this way, we lose detail, and if we come to the left, we gain detail, but it becomes much more intensive to render. So if I throw a daylight on it so we can see what's going on better, you can see this feels much more like a full-on mesh, but it's definitely making my system chug. So I'm going to increase the ray epsilon a bit, and then on render time, we can bring it back down if we want to. But this makes it a lot more responsive. Now I'm just going to switch to path tracing because that's what I love, and I'm going to take my max samples down to 1000 and GI clamp down to 1. This is just kind of how I like to work. And that reset the ray epsilon, so I'm going to bring that back down a bit. All right, so let's just increase the power here to get our normal looking Vectron that we all know and love. And like, it can be pretty fun to just zoom in and mess with the ray epsilon. Bring up the exposure so we can see what's going on. And like, this is already kind of interesting and cool. You can go about texturing and coloring and lighting this, but let's not get distracted. Let's go back to where we were, and I'm going to increase the ray epsilon again so it doesn't crash my computer, and then bring my exposure back down. Okay, but one interesting thing I noticed is that when I back the camera away, I started to get this weird artifact where it looks like it's clipping, but instead of saying, oh, that's a mistake, I decided to roll with it. And one thing I noticed is that when I started to play with this bounding box, it almost looked like this animated growth. So if I dolly out with a 2 key and then zoom in by holding down 2 and right click, because remember, it only works if I'm further away physically from the object, but I want to fill my screen with the object too by zooming the focal length in. And then we take the bounding box here and start messing with this. It creates this animated growth, almost like an ink bleed or burn or something like that. All I'm doing is messing with these bounds here. So as I bring this down, you can see this happening. Now, one way to make this even more pronounced is if we actually expand some of these bounds. At some point, this Vectron will just fully disappear. And there, it's gone. And I'll zoom back in here so we can see what's going on. And it looks like I don't have any camera selected, so I'll just drop another camera in and put my Octane camera tag there and delete my other cameras. And I'll look through the camera. And then here, I just want to rotate around until I'm back to centered up on that Vectron, which is hard to do considering we're not seeing it at all right now. All we can look at is the bounding box, which is somewhere around here. So let's just kind of shift over. Now, if I go to my bounds here and start messing around with this, you can see we start animating the whole thing on. We're a little bit too close now, so let's back out a bit. And so now we can really start creating this really unique, weird growth animation. Don't ask me why this works, but I thought it was cool. And the other thing is, if I bring the Y boundaries down to maybe 100 or less, you can see we start creating this cross-sectioned MRI look, which is another way to get a more unique fractal. And then another obvious thing you can do is just pop it in a cloner. Let's go for a count of 5. And let's bring this down to say 15 or maybe 25. And then if we rotate it around, we start to get this kind of trippy coral-like formation. All right, I'm going to undo and show you guys something else I thought was pretty cool. Also, look at this weirdness. Now I'm just rotating the camera, and as I rotate around, at some point it fully disappears. So if you just animate your camera orbit, that could be another way to create some pretty bizarre animations. Now, my other favorite weird quirk that I stumbled upon has to do with the power setting. Though, if you notice, sometimes we lose our settings down here, so all you have to do is go back and hit compile. So sometimes this works where it doesn't really change the fractal, but other times I find that it does. So I'm not really sure. It's a little bit weird still. So we've seen what happens when we go to a higher power level and say I go beyond 10. Let's try 20. Okay, that's interesting. Let's go to 15. Let's try 11. You can see it just duplicates the fractal features more and more. So I don't think it gets that much more interesting beyond 11 or 12. But what happens if we go into a negative zone? Okay, so we get something like this, which is totally different and might feel like an error or a mistake, but this is where I was able to create way more inky, weird formations. For instance, watch what happens now if we animate the bounding box. And now let's say we zoom in on this. Look at this crazy detail. And now look what happens if we animate the bounding box. And if you remember this example, that's how I made this inky effect. Literally just animating the bounding box. Alright, so before we move on to the more developed looks that I showed you earlier, I wanted to give you a taste of what's possible just by messing around with some different shaders, just to hopefully inspire some creativity in you and show you some things you may not have thought of. Okay, so we can add any kind of material we want to this, so let's just start out with a glass. Let's drop that on there. It's looking pretty different already. Now let's pop in a daylight, and then if we want to see this with our white background again, we can just put a texture environment back in. And in the daylight, we can set this to mixed sky texture. So that's just an easy way to flip between black and white, depending if we want to see a dark look or a bright one. Let's try to get this centered up so we can actually control it in the viewport here. So I'm going to pop it under the camera here and reset PSR. Then I'll take it out of the camera. And now we still can't see it, but if we pop out of the camera, we'll see that it's sitting right in front of the lens. So let's just pull this a little forward so we should be able to control it now. There we go. And I'll just swing this around until I get some lighting that I like a bit better. And one thing that could really affect this is the roughness of the material. So let's come up here to roughness and crank this up. You can see that's really making a difference. Now, what if we go back into our node editor here and play with some other stuff? Like, for instance, let's go to film layer and crank up the float on that. Okay, so that's really pretty. We're getting all these pearly colors. Let's turn on fake shadows. And just so we can see what that's doing, let's go compare store render buffer and let's turn it off. And like usual with fake shadows, that's just letting a little bit more light in, so I think I'll go with that. Let's turn it back on here. Okay, what if we vary the roughness across the surface with an image texture? Okay, that's immediately gone back to 0 roughness. And let's just pull in a weird texture like this. And it's not really clear what's going on, so let's actually change this from specular to diffuse. And here we can even solo this node and get an even more clear idea of how this texture is mapping to the Vectron object. So let's hit UV transform. And as we scale it up and down, literally nothing is happening, which isn't that surprising because this is a fractal form and I don't think it has any kind of discernible UVs. So the best way is going to be changing it to some other kind of projection type. So if we hit projection here, let's bring this down and let's change this to box. And now we can already see this is mapping in an interesting way. Okay, let's disable this solo node. And then let's pop this in the diffuse. And now we can see it having an effect. But let's go back to our previous specular material. And now if we kill this old link, which isn't linking to anything anymore, and reconnect it to the roughness, we actually are affecting the roughness across the surface, but it's not having as much of an effect as I'd like. So maybe instead we go into the transmission, which is definitely going to have a bigger effect. Because with specular materials, transmission is kind of like the diffuse slot. And also, maybe this material is kind of boring. So let's just embrace this trippy DMT art vibe we have going on and pick something crazy like this. I don't know what the hell that is, but let's do it. Okay, that's kind of cool. That might look better with some more interesting lighting. Let's disconnect this for a second and let me show you one more thing before we continue with that. Another way we can introduce color would be through a scattering medium. And then if we grab 2 RGB spectrums and put them into the scattering and absorption, that's already looking pretty cool. But let's take off the film layer real quick so that we can just look at the scattering and what that's introducing. So we'll just remember this was around 0.31. Okay, so let's come back here. And the density is also going to have a big impact. But when I introduce a color here, say I introduce a green, what I'm expecting to see is some green and some color opposite, which would be pink or magenta. So green and magenta, cyan and orange, that kind of thing. And it's not very apparent yet, but if we crank up the density a bit, now we're starting to get those hits of pink. So instead of green, let's choose, I don't know, let's try cyan. That's kind of nice. So we're getting cyan and red. Let's try a color for the scattering as well. Let's see what happens if we crank up a yellow. We're introducing some pretty cool colors. Let's take down the density and see what happens. It all kind of blends back if we do that, so I was actually liking it more before. Okay, and what if we take our daylight and try to backlight this thing? So let's just bring it up towards the camera. And it's kind of hard to tell what's going on, so this is a new trick that I like to do, courtesy of my good friend Ryan Talbot. So if we go to panel here, let's go to new view panel. And so this just gives us new perspective view, and we can dock this right here. And so now I can kind of orbit my scene, and it's similar to going up to options, untick, check camera, but for me this is even easier sometimes. I still like having this option too, but it just depends on the situation. Okay, and now I can see what's going on. The daylight is pointed towards the camera, but it's at such a low angle that we're getting these extreme orange colors. So let's bring it down a little bit, and that should bring in more of that yellowy color. Maybe even more. There we go. And remember, we can always pop back to that white background. And now if we want to let more light through, we can always adjust the density. Let's try bringing that down. But I'm going to hit undo a few times because I actually liked what we were doing before better. Okay, so I just hit re-render and the colors shifted, so we're not getting that same blue, but that's okay. We're just experimenting, so I'm just going to roll with it. And let's reintroduce our film layer here. This was at 0.31. And already this could be something pretty cool to animate. Like imagine if we animate the power, this would look really inky and complex as a pattern, or maybe we could just render it out and use it as an animated texture mapped onto something else in another project entirely. So if we come back here to animate it, we've lost the controls again, and when we hit compile, it jumps off somewhere crazy, unfortunately. So we just have to take the power back to a negative value. And we're not going to get the exact same thing as we had before, but we'll get something super crazy and unique. So it doesn't matter that much. Also, keep in mind the way we've colorized this, if we bring it to a positive value, we'll get some pretty interesting results as well. So this thing is cool in its own right. What if we go over to our panel here, do a new view panel, and pop that over here. Instead of our daylight, let's shut that off for a second. And let's set this background to black here. And let's just drop in an area light. And bring this back. And a little bit forward. And rotate it towards the object. There we go. Now we're starting to see something. Let's get an area light in front as well, just to give it a bit of fill. Maybe a little less high powered on this one. Let's pop in a C40 Octane Gaussian spectrum into the distribution. Let's bring the wavelength down and the width down. And now we can shift the color. And then let's put one over here as well. And maybe with this one, we change the Gaussian spectrum a bit. And here I'm going to boost the power. And in our Octane camera tag, let's change this saturate to white all the way up to white, so we get some more natural colors going on. Maybe this would look cooler vertical, so let's dock the window over here. Let's copy this light tag over so that our backlight inherits the Gaussian spectrum as well. And then let's shift this around as well. And then let's really boost the power of this because it's the backlight. So I can see the yellow coming through this subsurface scattering deal here. So maybe if we bring down the density, we'll see it come through the model a bit more. Let's just pull this way down and see what happens. Let's make sure we're seeing the correct thing, so let's re-render. There we go. Now we're starting to see through this a lot more. So obviously this is too bright at this point. And let's just make sure we're looking at the right light here. We could move this even more behind the subject. Okay, and then obviously we don't want to see the light, so let's take the opacity down to 0. And just to double check what contribution this is making, let's turn it off for a second. Yeah, see, it's bringing in the light that goes here. If we turn off the other two, we can really see it. That's pretty cool and alien right there. Okay, let's turn these lights back on. Okay, and I brought this blue light around a little bit more to the side because I want this to be a bit more moody. Let's try the same thing with the red light. There we go, that way we get some shadow. And now if we shift the backlight around a little bit, I kind of like that. That feels a little bit creepy, like the red is bleeding through here, and we're really just seeing different shades of blue and red versus that yellow that was being introduced. And now maybe to tie it all together, let's add in a LUT. Let's try Vision X. It's kind of cool. It's a little bit washed out. Let's try Vision 4. Or actually, let's take the redness of the light down. If we jump into the Gaussian spectrum and bring up the width a little bit, that should reduce the saturation. But also, let's take down the power. We could even turn this off temporarily. It would help if I would actually name this backlight. Don't be me, kids. Blue, red backlight. Now the question is this red adding anything extra here? And I think it's kind of cool to see a little bit more detail, but maybe we'll just take it down even more. So that way we're kind of seeing into the shadows, we're seeing a little bit of detail, but it's still moody and dark in there. And the fun comes in when you just start exploring this fractal weirdness that you've created. So let's zoom out here and explore different parts of this thing. And let's stretch this out so we can see things a bit better. Maybe I'll stack these vertically. It's a bit easier to navigate. So this is the entire fractal right now. And if you remember from back earlier, this is just a slice of the thing. So we could also play with the bounding box to get a really different look. I like this part. It feels like a gross crab to me. So this is how thin our slice is right now. So let's make this a bit bigger. There are just so many moments when you're playing with this thing that are like, what the heck is this thing and what have I done? Also, keep in mind if you want to see this stuff render faster, because it's going really, really slow right now, crank up your ray epsilon. And it'll get way less detailed, but it's still really cool looking. I mean, this could be an interesting look in its own right. And I just changed the camera angle and found this bizarreness just sitting here waiting for me. Okay, I've taken the ray epsilon back up so we can work with this more easily. And now I'm just going to mess with the power. And we can expand this bounding box back out to get the full sphere. And these are the kind of features I'm getting with the power in the negative zone. And at this point, I feel like there's too much red coming through, so I'm going to decrease the red backlight. I definitely like this area here. It kind of feels like swirly Jupiter cloud patterns to me. Okay, so it can be pretty difficult to navigate around this thing because there's literally no geometry in the viewport. And if I try to rotate, it just takes me off all crazy. So what we can do is we can drop in a cube. And like we did with the daylight, let's just put this underneath the camera and reset PSR, and let's scale it way down. And then in my second window here, I can just bring it forward and scale it down even more. And make sure that it's intersecting with the fractal. So as we bring it closer to the lens, we'll see it pop through the fractal. This should be good. So now if we rotate around the cube, we can move around the fractal and get different perspectives. So let's turn off the cube in the render, and maybe we want to play with some shallow depth of field. So let's come in here and let's crank up our aperture. Aspect ratio set to 2, aperture edge set to 3 like I do. And let's zoom in here, and maybe for now let's turn on autofocus. And let's make sure this light is set to 0 in the opacity. Let's take off autofocus and let's focus on something here. And now we're in the world of swirly paints. And I just cranked the lights a bit, raised the aperture, and picked focus around here, and this is what I'm getting. And here's the same thing without shallow depth of field, so that makes a huge difference. Okay, now remember, if we pull out the bounding box, the object still stays pretty static, but if we make it too big, and we start rotating around, you can see things get a lot weirder. And this can be a really good thing. So now, as we get closer to this object, we get these crazy swirly patterns. So imagine just slowly animating the camera and seeing these swirls happen. Here's another idea. Let me give ourselves a little more room and bring up the node editor a bit. Now let's mess with this texture that we had earlier. If we put it in the transmission, we're not really getting anything great, though we can see it's mapping to all the different areas properly. So let's try out another new feature of Octane. It's called the universal shader. And by default, we're going to get this metallic material, which is cool, and you can totally experiment with metallic materials as well. You can even create mix or blend materials using a procedural noise. So like, say you had a noise and you cranked up the contrast, you could create patches of a glassy material versus a metal material and create a really unique look that way. But right now what I want to do is I actually want to get rid of the metalness. So we're just going to go to metallic and we're going to take this all the way down. Okay, so now we've got this different look. The albedo is basically the diffuse. And if we take this down, we should be a lot closer to where we were before with more of a specular type material. But if we use this now in the albedo slot, we're going to map that texture in a much more interesting way. Now let's compile this so we can get a little bit better control of it. And let's decrease the bounding box so that we have that slice going on again. And if we really want to see what's going on, we can solo this node. And there we go. Now we can really see how it's mapping. So let's increase the transform to full psychedelic. And let's disable this. And maybe let's see what the daylight looks like versus these colors. Let's bring this around with the north offset. And let's bring down the power. And now we're getting a very different and unique look. And we can go back to a more shallow depth of field. And maybe if we increase this bounding box again, we'll have a little more depth to play with. Now let's compare this to our original lighting scenario. Maybe we'll take down the amount of blue. Let's balance it a little bit. And we could always swing the red to a different wavelength. And same thing with the blue. And we can also play with the highlight compression or the exposure, but I kind of like where it is, a little bit overexposed. And we can bring down the ray epsilon, or actually bring up the ray epsilon. That's kind of neat right there. I'm just going to keep playing around until I find some more stuff I like. Bring some camera bloom in there. This is what it's looking like without the shallow depth of field. And again, if we make that bounding box overly large, crazy things start happening. Take that post-processing off again. Here's another thing we can do. Let's duplicate this texture and let's put something in the blackbody emission slot. Let's bring this way down. So this is a good way to really emphasize some colors, though it does kind of flatten things out a bit. Let's try a different texture. Oh, now we're crazy. Let's bring our gamma down. I'm going to render a slow camera push overnight, and I'll see you guys later. Alright, so this is what we got. Pretty gooey and cool looking and quite colorful. Alright, let's move on, and there was one other idea I had that I forgot to show you. Okay, let's take this background back to black. And here's another idea. Let's just drop in a new material, and let's overwrite the old one. And under the type here, let's scroll down to tune. And I'll just refresh so we can see what's going on. There we go. So let's boost the power of this. Actually, let's add in a tune light. So we can go to objects, we can go to tune lights and go to point light. And now we can colorize this a little bit. Or we can do objects, tune directional light. This is more like a sunlight, and we can rotate this around. And over here there's actually a tune tab, so we can add a tune diffuse ramp and a tune specular ramp. And these can further colorize things. So there we go. Now we've got this kind of gradient going on in the diffuse ramp. Let's see what happens if we mess with the specular ramp. Just adding in some random colors here. And let's move this point light around and see what different effects we get. And the outline thickness will also affect things a lot. So this is almost a little more vectory. Maybe we take this back to white. And obviously I couldn't get this specular ramp to do anything, so let's just disconnect this. There's a spot for outline color, which might be cool. So let's just add in an RGB spectrum here. And let's just make this something crazy so that we can actually see it. And let's bring up the outline thickness. So I wouldn't necessarily call these outlines so much as almost like a shadowing that happens. Just a different look I wanted to show you guys that's a bit flatter and might be useful for 2D design. And if you're doing like Illustrator or more vector-based graphics, could be cool. But I'm just going to pop in a diffuse material, go back to this look. Now I want to show you how I created this look here. And the secret was basically rendering a sequence of this gooey look, but then using that in a displacement map. So the best way to do that, though, rather than rendering it like this, would be to render a Z-pass. And I'll show you how to do that. So if we come over to our overall settings here, let's scooch this over so we can see what's going on. We go to Octane Render, Render Passes. Let's enable this. And I'll just name this something. Send it to a folder. I'll just save it to the same swirly file that I did. Swirly Z. We've already got a camera move set up. We're just doing that slow push into the fractal that creates that kind of organic gooey shape. And here under info passes, I'm going to twirl down and just tick on Z depth here. And now down here we can actually look at our Z depth pass. Now I want to make sure we actually have a background in here, so let's put a plane behind our fractal. So let's just drop in a plane here, and we'll rotate it so that it's facing camera like that. And actually let's move it pretty far behind so that we get a lot more fall off and scale it way up. So that way it's just sitting behind our fractal and allows us to have white in the far background. Now if we go back to our settings here, and I'm going to keep moving this around, we can play with our Z-depth max, and this will adjust the values of what's considered close to camera and further away from camera. Now right now we're seeing something that's pretty flattened, and I don't necessarily like that. Remember how we crunched our bounding box down? Let's extend that out so we actually get more depth in our fractal. And the Z-depth pass might make a little more sense if we look at it with the power at a positive number, where the objects closer to camera are a little bit darker, and as we go further away they fall off into white. So I can adjust that with the Z-depth max here, but I actually am going to go for this negative value, even though it's totally tripping out Octane as to what's close and what's far, and it doesn't make a whole lot of sense. It'll still make a really cool displacement map. And there actually is a lot of detail in there, and subtle gradations that we're not really seeing very clearly here, but are actually there. Now, to only render the Z-pass, what I can do is, under my save, I can just untick this, but I also don't want to be rendering out all the samples for our beauty pass, so I can just literally take this down to 1. So it'll spend the least amount of time on the beauty pass possible, and then here, it'll spend 128 samples, which is pretty low. It should go pretty quick on the Z-pass. And to save a little space, rather than EXR, I'm going to do TIFF, because TIFFs make really good displacement maps, and I'm going to set it to 32-bit. And that way we'll have the cleanest possible displacement map. Alright, I'm going to render this out, and you can see it's going really fast. And under our layer, if we select single pass, it's going to look a little crazy. We could have avoided this if our settings were instead of linear, sRGB, and tone mapped, but in this case I'm fine with it being linear. It doesn't really matter to me that much either way. This just gives us more leverage and flexibility with it if we want to treat it in After Effects. And to show you that all the values are still there, we can just go to our filter here, enable filter, and then we can bring down the exposure, and you'll see that all that information is still there in the overbrights. This could also be a way to really quickly preview the motion of your Vectron object because it renders so fast and we're seeing the motion really clearly here. Alright, so it looks like I screwed up the settings, but I want to show you this just in case you run into the same things. So this multi-layer file tick box means that it will pack all these different passes, whatever you want, into a single file. And usually that's okay because in After Effects or whatever compositing software you use, whether it's Fusion or Nuke, you can pull that in and split out the different channels. So in this case, it's coming in as this black file and it recognizes it's a linear color space, but when I bring it in here, if I go to extractor, which is the usual way that you'll extract channels in After Effects, I'm getting this message, no auxiliary channels available, so I'm not able to recover this here. And if I put a curves on it or something like that, then nothing happens. There's no information there. But if I go back to my picture viewer, provided that I haven't yet closed this down, what I can do is I can save this out and I can go animation, TIFF, 32 bits per channel, and set it from my frame range 0 to 120 and hit OK. And I'll just save it to the same folder, call it Z pass. And so that's going to go back through the picture viewer and save out the whole image sequence. And now when we bring this into After Effects and make sure we're in 32-bit per channel, we'll see something similar to what we saw before. Let's throw it in a new comp, and let's put down a curves and bring down the white point, and we should start to recover that detail. So we could even crush this down a bit more and try to emphasize that contrast a little bit and make sure white is just touching white, and then we can re-render this. But if you're like me and you want to just bypass After Effects entirely and be super lazy, I'll show you how to deal with this without going through that rigmarole. So back in our project, here's the other thing. I actually want to render a square texture. So I'm going to choose, rather than this Instagram format, I'm going to do something like 4000 by 4000, which sounds like a lot, but it renders really fast, so it's not that big a deal. And this way we get a much larger texture to do displacement with. And now in our Octane Render settings here, instead of a multi-layer file, not a multi-layer, and I'm just going to do sRGB and tone mapped, so what we see is what we get. Okay, let's re-render that. You can see we're getting exactly what we saw in the live viewer, and we can then turn around and use this directly back in Octane. Alright, so this is my next setup. It's extremely simple, and if I zoom out here, you can see it's just a single plane with a few different lights sitting around to cast some different colors on parts of the geometry that are going to get displaced. And now let's pull this over here so we can make room for the node editor. And so what I'm doing is I'm just creating a glossy material. Let's drop that on here. And let's go in the Octane editor and let's take the diffuse all the way down. And I'm actually going to start with a bluish metal. So let's drag this index up here and let's drag up the roughness a bit. And there we can see our lights getting picked up. And let's change the specular to kind of a cobalt. A bit more cyan maybe. Okay, so that's our metal. Then I'm just going to drop in a displacement. And we'll set it to 4K because that's what we rendered out. We'll bring in our image texture. And then I'll find my Z-pass. And there we're getting displacement from our Vectron render. And now I'm going to set the animation here. I think I only rendered out 30 frames, so let's go see. We've got 33 as the last frame before I stopped it. So let's go to our image texture here and go to animation and say the end frame is 33, the frame rate is 24. And now to check that we're getting animation, let's go compare store render buffer and let's move to a different frame, wait for it to refresh, and yeah, we are getting animation. So that's looking cool. Now with the fractal previously, because it wasn't real geometry and for other reasons that I don't totally understand, the dirt node doesn't really work. I think it would have to be a situation where it's like true geometry, but at this point we've kind of converted our fractal into geometry. So if we just drag this into the diffuse, you can see we're getting a pretty interesting look already. So what this is doing is if we increase the radius of this, maybe invert the normal, and let's bring the displacement down to like 1 or maybe 2. Let's try inverting this image. So there you can see the dirt node is kind of bringing in this white diffuse texture, which under the lighting kind of feels like paper. And then we're getting these metallic blue edges that we could emphasize here. So if we go back to our specular, let's just make this a bit brighter. And let's take our roughness back down. And let's take the displacement down as well. And if I show you this previous example here, these are the settings I used on the dirt node. And you can see what happens if we take this down. This is kind of just the displacement, which is kind of creepy and interesting in its own right. But as we bring in this radius, we're getting the edges more and more taking over. And we could invert the normal to get a different look. And if I jump out here, you can really see what's going on. We're kind of taking all of this information from the fractal that had a lot of depth and flattening it down. That we could also go the other route and kind of bring it back out and increase the amount of displacement and get something a little bit different. And maybe for this we could reduce the amount of the dirt shader going on, or we could invert the normal for something different. But I think this displacement map in general worked better, because if we look at the source, you can see there's more gradation in here. So maybe let's go back to the drawing board and try a different fractal. Okay, I'm going to increase my samples back up here so that we can actually see what's going on. And let's take this Vectron and reset and compile. And let's see what this looks like as a Z-pass. Okay, so I've moved the camera around a little bit. I played with the object bounds a bit more as well. And here, this looks okay, but what you can see if I go here to my render settings, if I crank up the Z-pass, at some point we start to fade the back part of the fractal off. So right now I've made sure we have a bit more depth in the fall off of this image by kind of peering over the edge of this fractal, as it were. So this is the bounding box, and I'm looking in perspective down the edge of it. So as we get closer, this is kind of cool. So maybe we do an effect like this and see what that looks like. Bring in our cube here. We could also render a sequence where we just rotate the camera and get something pretty unique that way. And I'll increase these bounds so we're not seeing the edge of this cube as we rotate around. So we could either push in or we could rotate around a bit. I think rotating downwards is giving some pretty interesting tearing effects, so maybe we'll do that. Let's just parent the camera to the cube. And we'll just rotate this value here. Make sure our keyframes are linear. Cool, let's give this a try. Cool, so this is what we're getting in our previous setup, animating between two frames here. It's moving in the liquidy, cool way that it does. And also we're getting these areas that are barely displaced that kind of look like line work versus other areas that are more displaced, and I like that too. Okay, let's reset and compile this Vectron. And now let's look at an entirely different type of fractal here. Okay, so instead of Mandelbulb text, let's go to Menger Sponge Boolean Extract. And at first this just looks like a weird cube with a chunk taken out of it. But if you come down here to the K value, you'll see that it can get pretty complex and interesting, and almost city-like. Now, let's bring down our ray epsilon so we get more detail here. And you can see this can get extremely complex, and we can actually like fly into this here. And let's spin this daylight around so that we can see things a bit better. Now if we look at our z-pass, we're not seeing much, but let's bring this z-max up. This makes a lot more sense. Okay, so here's the other crazy thing. All this is just based on this code and this math, and I don't know what any of this means, but I do know that things happen when I change it. So it's kind of mysterious and kind of weird, but say I come in here and just type in 2 here. I have no idea what's going to happen. Okay, well that didn't work, but let's try an even smaller change. So let's just go 3.1, and let's click off of it. And that did change the fractal formations. Now we're getting this even more defined grid pattern here. And shout out to my buddy Fabian Oberhammer, aka the Dizzy Viper, for giving me the idea to change the code in Vectron at all. I wouldn't have necessarily thought of that because it's so intimidating at first. Okay, I just changed this value, and now all of a sudden there's a much greater erosion that's happened in the fractal. And now it's pretty much gone. If we change this to 0, I wonder if it is fully formed. And there we go. So this is what controls the Boolean that's eating away at this thing. So let's just set it back to 1. Maybe go to 2. Use our friendly cube to rotate around here. Okay, that made it get a lot bigger. So let's type in 5. Seems to be that's as big as it can get. Well, that's weird. I don't know if I like that one. Okay, that's really interesting. Let's do that in a smaller increment. Okay, now this thing's looking all destroyed and chewed up. Oh, this is cool. Now we got a fuzzy fractal. Okay, this almost seemed to change the detail. Now it looks like these weird bricks. Whereas before at 8, you're getting a lot more detail. This is like taking away the resolution entirely. Simple fractal is simple. And of course, ray epsilon still has an effect. Bring this back to 8. Bring the ray epsilon back down. Okay, so somehow I've ended up with this super bizarre fractal that can animate from here using the K value to something like this. And if I show this in the z-pass and go back to my options here and change my z-depth max, that could be cool. And now I'm going to grab this plane and make sure that it is sitting behind my whole scene here, not necessarily cutting it off. Maybe it's something like that. I mean, that's pretty neat looking already. Alright, so this might be a cool place to start out with these crazy grid lines. Take my samples back down to 1. And so we'll be animating this here. Start on frame 0, add a keyframe for the K value, go to the end, and let's bring this up until we're looking like this. Let's try linear keyframes. Okay, and the other thing we can do at the same time is animate the camera. Maybe let's pan upwards a bit. And maybe let's ease this in so it doesn't happen so abruptly. So let's go back to our K value here. If we hit this, it'll just set this to the shortest length possible. So kind of like a linear keyframe. Maybe this needs to happen a little bit sooner. Okay, that's one possibility. Let's try a different camera angle. Let's switch back over to the main so we can see this whole thing. This cube isn't really helping that much anymore. Let's move it back. Okay, so I'm finding this angle a lot more interesting, and the animation when I pull this keyframe's easing out is a little bit better, where we start on this crazy looking grid and it gradually unfolds to do whatever the heck this is. But when I pause on a frame and let it render, it looks really cool too, like this infinite staircase or geometric craziness. I don't even know how to describe this stuff, but it's cool. So this could work, I think, as a regular animation with some lighting and some volumetrics, which we'll get into in a little bit. But it can also work as this Z-pass here, which starts out like this and then opens up with all these crazy spikes. So I think I'll let this one bake out first, and then we'll take a look at what it does as a displacement map in our previous context. Alright, so I couldn't help myself, and I also rendered out this animation overnight of this fractal kind of unfolding. And I just used one simple specular material for the fractal, as well as a volume object and a light that's backlighting the scene. And I'll just break this down for you real quick. If I go Options, Untick Check Camera, and pull out of here, I'll show you what this setup's actually looking like. So let me turn off this plane, which is preventing us from seeing clearly here. And I'll delete these lights that aren't being used. So there's a daylight here that I'll move out of the way so it's not so confusing. And this is the main light that is just casting into the volume. You can see I can bring it forward. And it's set to a low opacity. If I bring up the opacity, it's going to blow out the camera. I can bring it down. And this is just clipping into our fractal and creating kind of an interesting little tunnel effect, and the light gets revealed as the fractal unfolds. And then my volume object is just sitting here. If I bring the voxels down, you'll be able to see it better. So I just made sure that the edge of it was buried somewhere inside the fractal so that we get some of this haloing of light, but not so close to the camera that it envelops the camera and we can't see the surface of the fractal. Alright, let's switch gears and move back to that papery looking scene where we can use our Z-pass. Alright, so I'm just going to replace this texture here. Come into our file. And I'll find our Z-pass here. And let's make sure this frame sequence fits the range, so I'll go to animation. 280 is not our last frame, so let's check this. It's going to be 120. And we'll set the end of the frame range to 120. So now we're getting a pretty interesting effect here. And if I crank up this displacement, we should see something really cool. So let's take down the dirt node, which is overpowering it a little bit. And this side's looking kind of nice, so let's check this out. Maybe that's too much displacement. Let's bring this down a bit. And we can also invert this shader to get a totally different effect, where this is more representative of the original scene we had, but it's still kind of compressed and not as deep as before, and I kind of like that. So I'm not liking how low res this is looking, and I actually didn't render it at 4K. I think I rendered it in Instagram format because I was focused on the volumetrics look, but I'm going to go back and render this at 4K. Alright, so I actually went back and rendered this at a full 8K, and you can see that the detail is just crazy now. So we're going to continue with this, and here's another cool thing. If I come down to this camera angle, and I untick this invert here, I'm really liking this look and angle here, and again, this is animated displacement. So if we scrub back here, we should see where it starts to build on. And I'm going to go ahead and render a bunch of these animation sequences and then come back to you. Alright, so this is the final sequence I came up with. I like it. It's pretty weird and cool. I wish there was a way to get motion blur on it, and it does look pretty chattery a lot of the time. Maybe not quite there for actual production work, where everything's got to be perfect and you wouldn't be able to get rid of those artifacts, but it's definitely fun to mess around with. So as I was recording this tutorial, Animate actually released a new update to Octane 2018, which is 2018.1 RC4, and now Vectron has this fancy new icon. And I'll fire up this render. And we'll come down to Vectron again, and there's a new preset that I just discovered called Quaternion Julia, whatever that means. And at first it seems like it's just a sphere, but the second we start playing with these, and we see we've got some pretty sweet looking, almost hair-like objects. Now, a lot of these sliders are just insane and out of control, so I would recommend using these arrows if you want to see it animating or doing some other cool stuff. And we can light it and texture it and put volumetrics around it like you've seen before, but I'm not going to go through that whole shindig again. But yeah, you should be able to see the possibilities for animation. This stuff is really insane and cool looking. And then of course, let's just drop a cube in there so we can actually navigate around the scene. I'll just hide it from the render here, and then we can spin around and see our weird object. And the iterations should be obvious. This is kind of like the detail of the fractal, like we've seen before. So it could be something more smooth like this. And then don't forget our friend ray epsilon, which will just allow us to zoom further and further into this fractal and see more and more detail. You see here we lose the detail, and then we can bring it back. At some point there's a diminishing return because we don't need to get that close to it, and it just takes longer to render. And here's an example of a render I did for funsies using this fractal type. And I also wanted to point this out. Amit, the genius plugin developer of Octane for C4D, created this insane fractal because he actually does know coding and can alter the code in an intelligent way. I don't really know how to get you guys to this other than telling you to type in this link up here, but if you scroll down, he posted the scene and the code here. So let's just grab this code, copy it, and we'll just paste it in here and say reset and compile. And then if we change the bubble size here, he's got some helpful controls. We get this pretty awesome, unique fractal. And let's take the bubble size down even more, and it's total Death Star madness up in here. Like before we get iterations and the scale, kind of like it here. And this is another really good example of getting closer and closer with ray epsilon. So if your ray epsilon's here, we've got a lot of detail, but say we wanted to go really, really close. Actually, I'm going to turn off this box right now because it's getting in the way. You can see by this point it gets really chewy, and ray epsilon isn't really helping yet, but there's also this issue with iterations. So if we increase the iterations, then we'll see tons more detail, and obviously it'll take a lot more time to render. And then we can just get even closer, take down the ray epsilon, and there's basically insane infinite detail going on. Now imagine lighting this and putting some volumetrics in and doing all of our sweet tricks like shallow depth of field and anamorphic bokeh, and you're creating art. Also, I finally went and rendered an animation of this scene, and I'd like to go and break it down for you. Okay, so I loaded the scene, and this looks a little different than when I rendered it. I'm assuming it's because we were just messing with the ray epsilon and that carried over. So if I bring this back, I think we should get back to the original look. And that was taking a really long time to render, so for the sake of speed, I'll just leave it here. And it might also have to do with the fact that I updated to RC4, so maybe there's something a little different in the code and how this is being processed. But regardless, this is close enough to what I had that we can kind of go through it. So here I've just got a couple Vectrons sitting together. And this first one has a really simple subsurface scattering material, just like we made earlier in the tutorial. And if you look here, I've animated the power so that we get some crazy movement. Pretty simple. Then I've taken this Vectron and duplicated it and scaled it down slightly. Normally you're in model mode, and if you try scaling this thing in model mode, it's actually not going to do anything. I guess we're seeing some little weird changes there, but I think that has more to do with the bounding box. Let's test this real quick. So if we're in this other Vectron and we're scaling this up, you can see there's no change to the scale, but as we scale it down, at some point it starts to clip. So that scaling operation is really just the bounding box. So instead of model, if we come to object mode and scale it, now we'll see we're actually scaling up and down this Vectron shape. So basically I just have the exact same Vectron sitting underneath it, and I scaled it down ever so slightly, so it's kind of like an inner light coming from within this subsurface object, which tends to create a little bit of an inner glow, or just kept it more to the ridges and outside, so the whole thing wasn't glowing. If it's too big, then you get something happening like this, where it's just a little overpowering. You can see here, this is not the effect I wanted. Now, to get them in sync with each other, you could do something like go to expressions, set driver, and then go to expressions, set driven, absolute, so that the one value is following the other. But it was weird, when I tried rendering this, I had some errors where the one that had set driven was frozen, so that didn't actually work. So ultimately I just copied the keyframes over, and I'll repeat that process for you here. So I'll blow away these keyframes, and you would think you could just go copy and then paste, but that doesn't work. Instead, there's this option under animation where you go copy track, and then you go animation paste track, and now if we look at our keyframes, they're the same. Now, one of the main things that's driving the moodiness of this is obviously the volume object, but we'll cover that in a second. Let's just turn this off for now. And I'll bring this down, and I'll create a new view panel here so we can look around the scene. Let's just dock this up here. Now, this is fairly difficult to comprehend what the hell's going on. So let me delete my other cameras out of the scene here. You can see I'm excellent at keeping my scenes organized. Okay, so this is our main camera here, and the icon is huge. So let's just take it and scale it down while we're in object mode. That's not going to actually affect anything other than the icon itself. And I kind of want to see what's in my camera's view and what's not. And right now, this is preventing me. And I can't really grab this and drag it out. If I drag these, then it'll change the focal length, which I don't want. Now, there's probably a better way to do this, but this is how I'm going to do it, which is coming over here to details and taking on depth of field rear blur, which just gives us another indicator of how far our camera is extending. So just kind of gives us an idea of what's in the shot and what's not, and where our camera is pointing. So the lighting setup is really simple. This daylight is more of just a fill, and the turbidity is set pretty high and really low power. If I crank this up, we'll see what that could be contributing, and this is really ugly and front lit, but with just a little bit, it's adding enough so that we can see into the shadows a bit. If I turn it off, these areas get a lot shadowier. So let's store the render buffer there so you can see that. You can see it's bringing in a little bit of light. This light's not being used, so I'll get rid of it. And this one here is kind of backlighting the scene. It's just a normal 6500, no real color in there. I guess I'd call that the key light in the scene. And actually it looks like that's it. There's not even another light contributing here from the other side. Our volume here is doing a lot of the work. The voxels are kind of arbitrary. I think this is small enough that this voxel size doesn't really make a big difference. If you go too low, it'll crash your computer, but right here it was fine. A lot of the time I take the voxels way higher, as you've probably seen in other tutorials. If we go into the medium here, now the volume step length is really high because that allows the scene to render faster. The lower you take it, sometimes the denser things get and the longer it takes to render. Though you've got to watch out for this sometimes because high volume step length can cause errors where objects in the far distance don't really fade off into the background and into the fog like they should. Here in the scattering and absorption, I've just got blue RGB spectrums, and that's creating this blue cast. Obviously, if I selected something different, we'd get a really different look. And the scattering phase is what's creating this directional feeling of the light. If this were at 0, the volume would be kind of everywhere and a general fog versus a volume that's more focused around the light. Here I've got several Vectron objects. Let's just bring these on one by one. So obviously these two are our central objects. Then there's this guy here, which is our main weird looking pyramid thing. If I hit compile, in this case, I actually get access to the controls again. Sometimes that works, sometimes it doesn't. I don't really know how to explain that. And if I bring down our K value, you can see we get more or less of this structure, and it's almost like an erosion factor. Pull back here and take our shallow depth of field off. You can kind of see this object a bit better. Again, this slider is out of control, so let's just use the arrows. And that's the kind of thing we're getting. Let's pop back to our main position here, and let's turn this one on. So this one's more of a foreground kind of deal. And as we rotate, you can see it's kind of crossing the foreground a bit. Let's pull back and take a look at this one. And similarly, if we hit compile, it doesn't actually jump anywhere, so that's good. And I think the other thing that I've done with these is really constrain the bounding boxes. You can see if I pull this out, we're getting much larger pieces, which could be cool for some scenes, but in this case I wanted just elements that felt like eroded pieces of old cities. Okay, and this is the background Vectron here, and this one I think is pretty large and complex. And I'll turn our shallow depth of field back on here, which is really focusing our eye towards the center. And then of course I've got my anamorphic bokeh going on with this aperture aspect ratio of 2 and the aperture edge of 3. This Octane sky is just a black RGB spectrum, which means that if the daylight's off, we're just filling the space with black. It's the same as if I were to come here to settings and then over to environment and change the default environment to black. But this way I get to control it with this RGB spectrum here. And if I wanted to introduce some fill light in this way, I could do so as well. Though if you don't have a background in there and fill this with more Vectron objects, it quickly becomes apparent that there's just gray mush back there. So that's not really very good. But you can see how it could act as a fill light here in the foreground. Okay, and last but not least, the camera move is extremely simple. I think I've got a null here in the center of the scene where these Vectron objects are, and all it's doing is rotating. I've got my keyframe set to linear, and here you can see the keyframe ends, but I've selected these keyframes and gone to functions track after, continue after, which is what continues this slope, so that wherever I drag this, it'll adapt. So I could make this really short, and our camera will move really fast, or I could make this a little longer, and it'll move more slowly, but I don't have to worry about where this keyframe begins and ends, because it'll interpolate the slope no matter what. So in general, I like pretty slow movement, so that's why I've got it over here. And this is literally just rotating on the heading axis. Camera's a child of the null, and it's like the most basic setup ever. But a lot of the time, that's all you need for a cinematic, nice feeling camera move. And if we look at our Vectron texture here, let's just turn off our volume so we can see what's going on. And let's actually make this brighter so we can see the texture more clearly. It looks like I've just created a hodgepodge of madness that doesn't even make that much sense to me right now as I look at it, but I'll attempt to explain it. So blend materials are just like mixed materials, except they exist all in one material. So in general, they're better and more useful. And here you can control the number of materials, and I've just got it set to 3, but it could be set to 2 because really I'm just mixing between 2 materials. Now, if we disconnect this and put a float into the amount here, we can slide this left and right to take a look at each material separately. So let's go all the way to the right. And here we've got kind of a cobalt metallic blue, which is really simple. It's just a glossy material with an RGB spectrum in the specular and an index of close to 8, so really reflective, and it's got some roughness. And now if we take our mount slider to the other side, you can see this is where we are getting our rainbow party. And here, this is actually a diffuse material. And in the diffuse channel, I've got a mixed texture node and some noises. One thing that's obviously happening is at some point we've got this texture, which is this weird thing. And that's got a color correction in it, which I'm not sure what this is even doing. If we disable this, compare store render buffer, and enable it again, you can see it's not doing anything. So let's just delete it I love how I'm doing detective work on my own mess here. So this is piped into texture 1, and then in texture 2, let's solo this. You can see I've just got some stacked noises to create different weird breakup, and I'm using this for a couple different things. So here, both of these are relatively similar scale, but just a couple different noises. And then up here, they're being mixed by this. So this one's really, really contrasty. I've slammed the contrast all the way up to 1000. And this is giving me big patches to mix between different noises and create a more complex noise overall. So when we look at this result all together, we're getting something a bit less repetitive, though I don't even know if that would have been really that much of an issue here, because there's so much complexity in the Vectron object that it's not really that easy to see repetitions. But in general, the theory is the same from my Advanced Octane Shaders Part 2 tutorial, which was just going through how you can create variation in scale with certain big forms and then smaller forms in the noise to create a more complex noise. So in our mixed texture here, if I solo this, so it's basically creating some areas where we're just seeing this, which is a black and white noise, and other areas where we're seeing this pathway, which is our rainbow party. Now, before, instead of this float slider, I was also using this same texture in our amount, which is what was doing the mix between this texture here and our metallic blue. So let's unsolo, and now we should be able to see the final look here, which is really just combining this metallic blue in certain areas and then the rainbow stuff in other areas. And if you remember this shot from earlier, let's take a look at this scene too, and I'll do another quick breakdown. So the texture is exactly the same as the previous shot, so I'm not going to go over that. And the Vectron objects are what we saw earlier, which was Menger, Sponge, Boolean, Extract, with some slight tweaks to random values in the code until I found something interesting. And here again, the scene is really simple. We've just got that same volume object, though it's not all the way up to the camera, so that the foreground is a lot darker. If it were enveloping the camera, then we'd get a lot more fog everywhere in the scene. And I wasn't liking how this was flattening everything out. So I preferred having a bit more of a cutoff here in the foreground so that we get some of those darker shadows. Now there's a separate Vectron here for the foreground. Let's see if I can find that. This guy. And you can see if we scrub over this way, this foreground Vectron has some pretty cool repetitions that feel like a tunnel. So I thought this would be a fun path for this little dude to kind of enter the scene and then exit and come right up to the camera. Now I could have just easily keyframed the focal depth here, but instead I've got it set on the object to a focus object, which is this null here. And the null is inside this model here so that wherever it travels, the focus will track with him. At the same time, I also animate down the aperture because here with the same value of 1, the depth of field gets so shallow that it's extremely distracting and we can't see any of the rest of the scene. But out here I liked it at a value close to 1. Now if we look at the top of the shot, the lighting setup is super simple again. This side light here is a little bit more on the warm side, and because of the LUT on the camera, as well as the settings in our volume object, this is coming across more green than yellow. If this were set to a white, then we get more of the true color of the light, but I liked it green. And if we look over here, this light appears to be more blue, and you can see it's just default 6500, so pretty simple. And without the greenish light, we get a different look, which is also dramatic and interesting. All right, so that was a lot of stuff, but I hope you picked up a bunch of tips and tricks along the way, and I hope it inspired you to pick this weird and nifty tool up and start experimenting with it yourself. I bet there's a lot of other weird things you can do with it, and this is only the beginning for Vectron. There's going to be a lot more art directable controls in the future, and hopefully you saw what is possible by looking at films like Guardians of the Galaxy and those other tools and other programs like Unity, etc. Anyway, I'll catch you guys next time. Bye-bye.